Hi everybody, my name is Erin Kim and it's an honor to be here representing New Harvest. New Harvest is a New York-based nonprofit accelerating breakthroughs in cellular agriculture, which we've been doing as a very small team since 2004. The new field of science that we're building involves the production of animal-derived agricultural products like food, such as meat, milk, and eggs, and materials like leather, silk, and bone from the cellular level through biotechnology, whether through cell culture, fermentation, or other methods not involving whole animals. It's a subject that's been receiving quite a bit of attention in the past couple of years, mostly for its application towards cultured or lab-grown meat. This is an emerging discipline which lies at the unlikely intersection of medicine and food science, using advances in tissue engineering or the growth of human tissues for medical applications, and applying these principles to growing proteins, cells, tissues, and molecular ingredients for food and other uses. Rather than sourcing these from whole animals, we can produce some of these by either employing yeast to make them for us, as in the case of acellular products like milk proteins and gelatin, or by growing them cell by cell for cellular products such as meat and leather. Things have gotten really interesting for this field over the past 5 years or so it may help to summarize some of the key events that have taken place since 2013. The televised tasting of Mark Poss' cultured beef hamburger prototype in 2013 was, without a doubt, the single event that launched the international interest in cultured meat that continues to this day. It was made at a famously high cost of 250,000 euros and many months of culturing each of the 20,000 cow muscle fibers by hand and then coloring them red with beet juice. It also didn't taste very good. 2014 saw the first few acellular agriculture food startups being founded, 2 of which were direct spin-outs from New Harvest. Perfect Day Foods, who were making dairy milk proteins from engineered yeast, and Clara Foods, who are using a similar process to produce egg white proteins. But as all this startup activity was stirring, we were realizing that we needed new words to describe this nascent field and industry. And so the phrase cellular agriculture was coined on our humble Facebook community page in 2015, not that long ago. And since then, usage of these words has gone viral, expanding from just that few hundred people in our tiny online community at the time to adoption by NASA and the American National Academy of Sciences, and the MacArthur Foundation were relatively early adopters as well. From about 2016 onwards, interest in cellular agriculture has been steadily skyrocketing, and the number of media articles about cultured meat in particular has gone off the charts. New startups continue to form at an accelerating pace from countries including the US, Canada, the UK, the Netherlands, Japan, and Israel. And cultured meat is by far the most anticipated application of cellular agriculture. But it's an area of research that still remains oddly neglected. What we need before products can actually reach dinner plates is a product pipeline. And before that, we need a foundation of openly accessible scientific research. But to take a step even further back, what's the point of investing all of this time, energy, and funding into cellular agriculture research? Well, it's old news to all of us by now that large-scale animal agriculture comes with certain consequences to the environment. It's a very linear and wasteful production system. And cellular agriculture, on the other hand, has potential for creating meat and other animal products from cell cultures, and not from whole animals, which suggests that we may someday be able to produce and consume the same foods and materials using less water and land and emitting fewer greenhouse gas emissions. However, it must be stressed that although these are very exciting possibilities, all of the beneficial claims that are being made are purely speculative until there are tangible products that can be studied independently and not just prototypes. As it stands today, there isn't yet enough evidence to support whether or not the proposed benefits will be realized, and to what extent, if so. So if we're not quite at the stage of having cellular agriculture products ready for the market, what exactly is the state of research today? This may be easier to frame in terms of what we still don't have, which includes, but is not limited to, a standardized source of cells for each animal and tissue type, whether that's a species of cow, pig, chicken, or fish, and all of the cell types that make up a cut of meat, so not just muscle, but also fat, connective tissue, and blood, for example. We also don't have a method of producing enough of these cells affordably and sustainably to be able to produce even a high-cost product, let alone one suitable for mass consumption. And most importantly, we're just getting started in terms of generating expertise specific to cultured meat to be generated in an openly accessible setting. Cellular agriculture is an interdisciplinary field, but there aren't yet any courses or degree programs being offered at a university level. There isn't even a textbook yet. Academic, peer-reviewed scientific papers on this subject remain few and far between, which isn't entirely surprising because this is a very new field of science that we're building as we go. From a non-technical standpoint, we also don't know if cultured meat, once produced at scale, will taste the same as conventional meat, or if it'll taste different, for better or for worse. We also don't know how cellular agriculture food products will be regulated. There are some preliminary moves being made in the US by groups both for and against cultured meat, but again, as the nature of this field remains so highly speculative at this point, it's unclear how exactly end products will be regulated. Although it was just announced a few days ago that cellular agriculture food products will fall under the FDA's jurisdiction in the US. And of course, it isn't yet known when exactly cultured meat or other cell-cultured food products will be available. Predictions have been coming and going for quite some time, and with most research taking place behind closed doors, it's anyone's guess. There have been bolder predictions being made over the past few years, but still no products on the market to date. Now, what's being done to address these unknowns? New Harvest is tackling the technical side of things. We're funding an international network of cultured meat scientists and creating a quite unusual atmosphere of openness and collaboration amongst researchers. Our fellows are also required to publish their work in open access journals, something that would be basically unheard of if the landscape were composed of just companies alone. Through New Harvest channels, the public is learning alongside us in real time about basic cultured meat concepts like vascularization, which is depicted on the top right slide, or the formation of blood vessels in vitro. What we're looking at on the top left is some fibroblasts in culture, which are precursors to connective tissue. And on the bottom slide, we have meat just bought from the store, looked at under a microscope. So it shows that there is still quite a bit of a ways to go in terms of the research. It's extremely important to us that we communicate the progress of this work in an honest and science-based manner. That means sharing the exciting and positive developments in this field, but also being truthful about some of the challenges, such as the fact that cultured meat is not quite totally animal-free yet, as much of the research is still dependent upon animal serums as a culture medium, and that very often in science, you run into unforeseen roadblocks like cell death and your culture is getting contaminated, and processes that can be excruciatingly repetitive, slow-moving, and boring, quite frankly. Our approach doesn't always lead to the most exciting of news headlines, but we are playing a longer game in generating more trust in the field and building meaningful, productive relationships with players from many different worlds, whether that's academia, government, or even the existing meat industry. I'd like to conclude with two quotes from Carl Sagan, which I think capture two takeaways about New Harvest and cellular agriculture. The first is a simple one. With insufficient data, it is easy to go wrong. We in the cellular agriculture community have been doing a lot of talking about the potential benefits of what we're building, and it is amazing, but it's now time to back up some of that talk with hard evidence. The second quote is, if you want to make an apple pie from scratch, you must first create the universe. We're not simply trying to create one holy grail product of a cultured meat burger or steak. What New Harvest is doing is bigger. We're working on an entirely new foundation of knowledge which can be sustained and built upon into the future. And so we're approaching this work with a broader view to all that is needed to seed that universe. As Ellen mentioned in her opening, there is amazing potential and there is momentum building, but there is still quite a long way to go. Thank you.